Okay, in 11-5, we are talking about angle relationships in circles today. And before we get going, I want you to go ahead and pause the video and make sure you know how to do these warm-ups. The answers are here. It's important that you remember the difference between a central angle. Central angle is congruent to the arc measure, and inscribed angles are on the circle, and it's half of the arc measure. So today what we're doing is we are finding the measures of angles formed by lines. And if you recall, there have been three types of lines that we've talked about so far. We've talked about a chord. A chord, remember, is a line segment that hits the circle twice. So this is a chord. A secant is a line that keeps going and also hits the circle 2 times. And a tangent is a line or a line segment that hits the circle only 1 time. So there's my example of a tangent. And what we're going to do is we're going to see how these 3 lines, we can use those 3 lines to find measures of angles and measures of arcs. So there are really 3 different types of problems that we're doing today. The first problem, and these can get really confusing. There's some pretty advanced pictures that we're going to be looking at. So I want you to take note of where is the vertex of the angle. The first thing we're going to say is, okay, what happens if the vertex of the angle is actually on the circle? So that could be sometimes called we've learned already that that's also called an inscribed angle. So for example, in this picture, the vertex of angle 1 is on the circle. When that happens, we've already learned in 11.5 that if this arc is 120 that it intercepts, this arc right here is in between the angle, right? So if this is 120, the angle is going to be half of it, so it's 60 degrees. Same thing if it looks like this. It's a little bit different, but if you can notice, the vertex is still on the circle, much like the inscribed angle. So if this arc, which is in between those 2 rays, is 200 degrees, then that means that this whole angle has to be 100 degrees. Okay, so that's the first type of question we're going to be dealing with. Here are some examples. Let's say, for example, again, I told you that this could look a little confusing. This one, they wanted to find out what measure of angle EFH is. Okay, so measure of angle EFH, let's see. That is, I don't know what I just pressed, sorry. That is EFH. That's this one right here. Okay, so if you notice, that angle is, that vertex is actually on the circle. Here's the vertex. So what that means is this intercepted arc, 130 degrees, this is going to be bigger, right? So that means to find the angle, you have to divide by 2 because the angle is going to be smaller. So your answer for that one is what? 65 degrees? Sweet. For this one, they want to know what the arc GF is. So arc GF, remember since there's only 2 letters, that means that it's talking about a minor arc. So we're talking about the shortest distance between G to F, is this one right here. All right, so what can we use to find this? Well, we need to know about some angles here. We need to know what this inscribed angle, or I'm sorry, this angle is. Notice the vertex is on the circle. So if you notice that 122 degrees is a linear pair. So that means that if you add these 2 up, they equal 180 degrees. So 180 minus 122, that's going to be, what, 58 degrees? So this angle right here is 58 degrees. Now, if we want to figure out what the arc is bigger, so you're going to multiply by 2. So 58 times 2 is going to be 116 degrees. So measure of arc GF is 116 degrees. Okay, so again, the important thing that I want you to notice, if the vertex is on the circle, then it's just like an inscribed angle, and that the angle is going to be half of whatever the arc measure is. Okay, so here is problem 1 and 2 that you're going to do tonight. Let's see, erase. Okay, 1 and 2. So you can title this one numero uno, and this one number 2. Okay, so that's the first type of question that we're doing. The vertex, again, is on the circle. The second type of problem you're going to see, what happens if the vertex is in the circle? Here it is right here. Okay, so 1 and 2. Okay, so we've already talked about on a circle, it's just going to be half. If it's in a circle, if you notice in this one, this vertex is inside the circle. This is formed by 2 secants. Sometimes it's formed by 2 chords. What's going to happen is you're going to take these opposite arcs. You're going to add them up and divide by 2. So I would write for this second formula, you're going to take arc 1 plus arc 2 and divide it by 2. And remember, I would also write down that the arcs are opposite of the angle. And remember, this is always when the vertex is inside the circle. So here are some examples. Oops, that's not what I wanted. So some examples. Let's see. This one. Okay. In this one, if you notice, the vertex is inside the circle. So what that means is we're going to have to take, and we want to find AEB. So we want to figure out what this angle is right here. And the vertex is inside. So what that means we're going to do is we're going to take the arc, the first arc, add it to the second arc, and divide it by 2. And remember, these are opposite of each other. So one arc that's across from it is 139 degrees. The other arc that's across from it is 113 degrees. Add them up, divided by 2, that's going to be what your answer is. Okay? The other type of question I could ask you is, I'm going to ask you not for the angle, but I'm going to ask you for an arc. So we kind of have to work backwards, but we're going to still use the same formula. So where is there an example? Here, oops, here's an example of that. Nope, that's not an example. Really? They didn't give me any of these? All right, I'm just going to come up with my own because I'm that good. You can title, let's see, another type of question I could give you is, let's say, I'm going to scribble that out. I don't like that number either. I'm going to say that this is 20 degrees. And I'm going to say that this angle is 60 degrees. And I want to figure out how long this arc is. So I want to know what's the measure of arc AD. All right, well, we know that basically we just have to average up. We have to add them up and divide by 2. So average these 2 arcs, and that'll equal the angle. So I could say that the angle is going to equal arc 1 plus arc 2, we'll call that x, divided by 2. So the opposite of dividing by 2 is multiplying by 2. So this is going to be 120. So we multiply both sides by 2, and this cancels out. 120 equals 20 plus x. Then subtract 20, and I get x equals 100 degrees. So this arc is 100 degrees. So those are the 2 different types of questions I can ask you. I'm either going to give you the angle and ask for an arc, or I'm going to give you the arcs and ask you for the angle. All right, so the third question you're going to do tonight and show me tomorrow is this question. So title this one number 3, please. And it's important that you remember, sorry, number 3 is slide 11. It's important that you remember that if the vertex is inside the circle, then all you're going to do is average the arcs across from it. So add them up, divide by 2. All right, the last type of example I could give you guys. We've talked about chords. We've talked about the vertex on the circle. We've talked about the vertex in the circle. The last one is what happens if the vertex is outside of a circle. This is the third and final example. Well, it kind of is similar to what happens when it's inside a circle. Remember, if it's inside, you add up the arcs and divide by 2. When it's outside, guess what? You subtract the arcs and divide by 2. So I would write arc minus arc divided by 2 equals the angle. And I want you to always remember that we're going to only, in geometry, we're always going to have positive angles. So if you get a negative answer, just switch it to a positive. All right, so some examples. Come on. All right, some examples. Here are some, we have some secants, and we want to find the value of x. So I'm asking you for the angle. I want to know what this angle is. And remember, if it's outside, you take the arcs, you subtract them, and you divide it by 2. And that equals the angle. So for this one, to find x, all you do is put the bigger one first so that we can have a nice positive number. So 87 minus 7 divided by 2 is, because these ones are opposite of each other, it's going to be 80 divided by 2, so your answer is 40 degrees. Same thing for here. This one's outside, so you just go 200 minus 74 divided by 2, and that'll be what x equals. The other type of question I could give you, of course, is I give you the angle, and I want you to find out one of the arcs. So let's see if they give us an example. Yes, here's one. Okay, so This one is a little bit harder, but because we have to work backwards, but same process. We want to find out what x is. This is outside. So remember, all you have to do is take the arcs and subtract them. And 83 degrees is going to be bigger. It's going to be bigger. And that'll equal what the angle is. Same thing that we did last time. The opposite of dividing by 2 is multiplying by 2. So we multiply both sides by 2, and we get 50 equals 83 minus x. And then if you subtract 83, we'll get negative x equals negative, what, 27? So x equals positive 27. Did I do that right? No, I think it's 23. Sorry. Negative 23. So x equals positive 23. No, oh my gosh, I did it wrong again. Sorry, negative 33. So x equals positive 33. All right. Okay, so it's basic algebra, and those are the 3 formulas that you'll want to remember, because I'll give you problems where I'm not going to tell you exactly which formula to use. So let's see. I want to do this problem with you guys. 2 of the 6 muscles that control eye movements are attached to the eyeball and intersect behind the eye. Very cool. What if AEB equals 225 degrees? That's important. This is major arc. So AEB, this whole thing is 225 degrees. What is measure of angle ACB? So I want to know what this is. And if you notice, this is outside the circle. So what that means is we're going to have to take the arcs and subtract them and then divide it by 2. But we only know what one of the arcs is. So some of you are saying like, come on, Ms. Broyles, you didn't give us enough information. Well, let's think about this. This whole thing, the eyeball, it is 360 degrees. So if this part is 225 degrees, this part, this minor arc, is going to be 360 minus 225. So let's see, 360 minus 225. That means that this is 135 degrees. So now I do know what all the arcs are, and I would do 225 minus 135 divided by 2, and that's going to be what x equals. Okay, so 225 minus 135 divided by 2, and you get that this angle right here is 45 degrees. So you just learned about some eye muscles. Very interesting. Okay, very cool. So again, just to recap what we did today, we talked about 3 different types of, 3 different formulas that you could use to find out what measures are in a triangle. And here's just one last question I'm going to give you guys. Yeah, so find measure of arc YZ. YZ, so the shortest distance. I'm going to say it's this one. I'm thinking that's what they want us to do. Okay, so let's see what information we can use. Okay, so we have this angle right here, and that's outside the circle. So to find an outer angle, that's going to be the arc minus the other arc divided by 2. And we know that this is 49 degrees. We don't know what this is, which is what we want to figure. I'll call that x. But we also don't know what this one is either. So, how can we figure out what that is? We'll call this y. This is going to be kind of a 2-step process. So if we can figure out what y is, then we can figure out what x is. Okay, so we're going to try to first find out what this is. So our first step is going to be figure out what arc uy is, which I'm just going to call y. Okay, so if you look at this stuff, well, I do know that this opposite one is 68 degrees, and I don't know what this one is, and this angle is 113 degrees. If this is 138 degrees, 13 degrees, this angle is supplementary, so 180 minus 113 is 67 degrees. And I'm going to hurry this up a little bit because I think I'm running out of time. So this is 67 degrees, and this is an inside one. So for the inside angles, that's when you add them up. So I'm going to add up 68 plus y divided by 2, and that should equal 67. So I do my math, multiply this by 2, 67 times 2, subtract my 68, and I should get that y equals 66 degrees. So make sure you got that. So this is now 66 degrees. That was the first thing I did. Now that I know what y is, I can now go back. This is my second step. Go back and plug it in here. So 49 equals x minus the 66 divided by 2, because these arcs are both within this 49 degrees. Okay, so multiply by 2 and you get 49 times 2 is 98 equals x minus 66. You add the 66 and you get that this x, this red arc, is 164 degrees YZ. All right, so there's 2 steps. That's the hardest type of question I can give you. And the last one I want you guys to work on tonight, number 4, title number 4, is this one. All right, so we just talked about angle measures and circles with chords and secants and all that jazz. All right, where'd my thing go? There it is. Thank you.